All right, we're going to pick up with question number 9. Question number 9 says, if forces always occur in pairs, how do we get unbalanced forces? Well, if we want to do a little bit of thinking, let's go back to number 8. And it says, yes, forces always occur in pairs. And it says when one object exerts a force on a second object, the second object exerts a force on the first object that's equal and in the opposite direction. Okay, so for instance, object A exerts a force on object B. Well, object B exerts an equal and opposite force back on object A. So the two equal and opposite forces, one of them's acting on object A, one of them is acting on object B. So they're not both acting on the same thing. That's how you can get unbalanced forces. Also, let's go to page 210 on lesson 3, because I think I had you write something in there. Yeah, so it says on page 210, if you wrote it down like you were supposed to, it says if forces occur in pairs, and they're always equal and opposite, then how do we get unbalanced forces? It's because those equal and opposite forces act on different objects. And a classic way to do these force pairs is, for instance, well, let's look at the kangaroo that they've got in the picture. It says a kangaroo's legs exert a force on the ground. Well, so you can state that as kangaroo pushes the ground back. The equal and opposite force would be the ground pushes the kangaroo forward. So, you know, if A does B, well, then B does A. For instance, if you've got a man pushing on a wall, like we've got here, okay? So a man pushes on the wall. Well, the wall actually pushes back on the man. So how would you state it? Well, object A pushes on object B. Then object B pushes back on object A. That's a force pair, okay? And if you notice, this is something that you should have had on the end of your notes in lesson 3. The man is standing there pushing with all of his strength on the wall, and you've got 1, 2, 3, 4 individual force pairs that you have to look at to get a complete picture of what's going on. Force pair number 1, man pushes wall. Equal and opposite force is wall pushes man. Man pushes the wall to the right, wall pushes the man to the left. And those two are equal and opposite. Okay? Man pushes down on the floor pushes up on the man, meaning that the floor supports the man. That's why he's not falling through it. Okay? Believe it or not, man exerts a pull on the earth that's equal and opposite to the earth pulling down on the man. Okay? Man pushes the ground backwards, the ground pushes the man forwards. Why is the man not going anywhere? Because when you look at the forces that are acting on just the man, the floor pushing the man up counteracts the earth pulling the man down. So those two are equal and opposite. Okay? Wall pushing the man to the left is the same as the same size and in opposite direction as the ground pushing the man to the right. So the guy's not going anywhere, and it's not because that the forces in the pairs act on both on him. It's just that the 4 things that are acting on the man all equal out. Okay, so anytime you're asked to state a force pair, it's just, you know, A exerts a force on B, B exerts a force back on A. Man pushes on wall, wall pushes on man. Okay? Ball is pulled down by the earth. Well, the earth is pulled up by the ball, believe it or not. Now, the earth is so massive that it basically goes nowhere. But that's how you state force pairs. Anyway, the big thing is, how do we get unbalanced forces? It's because those equal and opposite forces do not act on the same objects. Okay? We can think of like a bullet and a gun problem. you know, the explosive expanding gases that push the bullet forward. Okay, so gun exerts a forward force on the bullet. Well, the bullet actually exerts a backward force on the gun. That's why you have recoil when you fire a gun. So all of those things, they're equal and opposite, but the two forces that are equal and opposite aren't acting on the same object, so you can still have unbalanced forces. Okay? Okay, so once again, the two equal and opposite forces that we're talking about, one of them acts on one object and the other force acts on a different object. So even though you've got equal and opposite forces, you still can have acceleration because you can still have unbalanced forces. Okay? All right, number 10. What are two different ways to calculate acceleration? Well, we've actually already done that. We've answered both of those actually previously somewhere on this Bellworkk. So if you are given, if you want to find acceleration and you're given things like force and mass, then you can actually use this equation, okay? All right, so acceleration is your net force, like the sum of all the forces acting on an object, net force divided by mass. So you're going to use this equation if you're given force and mass, okay? But remember, we also have this other equation to calculate acceleration, and you would use this one if you're given velocity and time, okay? So depending on what information you have, that's going to determine which of the forces you use to which of the formulas you use to calculate acceleration. Okay, and that should probably wrap it up. Okay. So if you're given velocity and time, use that formula. If you're given force and mass, then you're going to have to calculate acceleration with this other formula. Okay, so it just depends on what you've been given in a problem or a situation that you're having to look at. All right, I think that does it for our Bellworkk.